Good morning, everyone. The title of my talk is Using Big Data to Make Intellectual Property a Strategic Weapon. Or in other words, using AI, artificial intelligence, in intellectual property. The data as is does not have much value unless you make some sense out of it. And AI, or in simpler words, analytics, can be a very powerful weapon in your toolbox, which can be used throughout the life cycle of any intellectual property. As part of this talk, I'll have a simple introduction and describe to you what is AI. There are so many wrong notions about AI, and we'll talk about what is AI and how is it important in the context of IP. We'll have a little deeper dive into the types of different AI and how they can be used in intellectual property, as well as what are the main aspects of AI. AI is a very large and growing field, so you don't have to know, and nobody can actually, even people who are experts in AI can know everything about AI. And as you develop your expertise, there will be a lot of new things coming up, so it's very difficult to catch up. So I'll try to describe it in very simpler terms as to what is AI. Secondly, we'll talk about how AI can impact the IP lifecycle in the future, and from the stage of ideation all the way to patent valuation and monetization. And finally, we'll conclude with what we have just discussed. To discuss what is artificial intelligence or AI in the context of intellectual property, you have to first find out what it is not. As I mentioned, there are many wrong notions or ideas about what is AI. So we'll first need to clear up those things. So what AI is not? Okay. First of all, it's not just little men inside a black box. It is not even a black box. I mean, you can always find out what are the techniques that are used within AI, and you can actually find out very clearly how these decisions are made. And that basic understanding of AI is very important for any field, particularly when you apply to something as intellectual property. Secondly, it is not something that imitates human intelligence. So a lot of people will tell you that AI is what, in a silicon form, what human does. It is not. Why it is not? Because we do not even know how human intelligence works. We have some notions as how it works, but even the psychologists or doctors are not very clear as to how human intelligence works. So since we do not know how it works, we cannot even imitate it. In fact, the human intelligence is possibly more of a black box than artificial intelligence. Also, it is not an automaton or a robot which does mundane work, though AI is used in the field of robotics, both for physical robots as well as software bots. But that doesn't mean that AI is robots. They are two completely different fields. AI is applied into robots. Robots need not have to have artificial intelligence. They can sometimes follow routine work by just algorithms. So we need to have this clear distinction as to the robotics and the field of AI. As I mentioned, it's very important to understand what is AI, so that it can be a very effective tool in your workbench of IP management. And the bottom line is AI does not replace human intelligence. What human is doing, you cannot just replace it with AI, but it's a rather a very important aid for your decision making. So what is artificial intelligence? Again, there are many ways to skin the cat, but for these discussions, it's good to know that there are some very basic AI methods which we'll be talking about. The more prominent one of them are statistical methods. So at the very basic, AI is just a set of statistical tools that can be used for making future decisions based on historical occurrences. So that's where the data comes in. I mean, when you talk about big data, these historical occurrences of all the data that you have make the big data. But ultimately, the goal of using that big data or the historical occurrences is to use for some future predictions. Most AI methods, most often the AI methods that are used are linear methods. They're simpler, and they are not just particularly used in AI, they're used in other engineering fields like chemical engineering, mechanical engineering, electrical engineering for statistical modeling. So they are not really something not native to the AI methodologies. They have been known to human for a long time. What is new for AI are some of the newer techniques are deep learning. Though I'm calling them new, they're already kind of 50 years old. They're not really new as so far we are concerned. But these are more complex techniques. They're more akin to using AI. And they use multiple learning steps where one step can either feed forward or feed back into the next or previous steps. So these are kind of some very basic, simple AI techniques that are used in big data. Looking into types of AI that we might be looking into, some of the most common using techniques are supervised learning. It uses human guidance for learning. So when human says, okay, this is a duck and this is a cat and this is a dog, the AI methods based on that human guidance will, when it next sees a duck, it will say it's a duck. When it sees a cat, it will say it's a cat. And when it says it's a dog, it will call it a dog. And usually they are the most accurate in predictive methods because human is actually guiding them to make the prediction. However, we human also do mistakes. Sometimes we have our inherent bias. Sometimes we just make simple errors. So in a supervised learning, an AI system can make mistakes if the human has some bias or some errors, which it pulled into that. If a human calls a cat a dog or a dog a cat, then AI will learn it from that as well. Okay. So unsupervised learning, it does not need any human guidance. It just tries to make its, given some data, it tries to make its own judgment. And interestingly, it can actually find, and sometimes often finds, aspects of patterns which are not known to human. It can classify things which are not known to human. And sometimes that's good, sometimes it's bad, because AI can also make mistakes. So even after in an unsupervised learning, it's good to have a human always supervising the results and making sure that it's not learning something which it does not need to learn. And because it's kind of, you switch on a button and then it does its decision and comes to a conclusion, it's sometimes difficult to understand why it came to a decision. Okay, but once you follow the patterns, and sometimes when you follow the algorithms, it can kind of try to come to a decision. The third or more uncommon or newer technology in the AI is a knowledge graph. And though knowledge graph has been used by many organizations for finding patterns, and this is not a statistical method, this is more a graphical method. And again, like unsupervised learning, it can discover new patterns, but it's also very computationally intensive because you have to store all the relationships and between different entities and how they relate to other relationships and to other relationships. It's computationally intensive. So when it comes to choice of whether you should be using supervised or unsupervised or knowledge graph, I would say that you should be using a toolbox which has everything. You cannot make a decision as to, shall I use this, shall I use that? So it's like you cannot use a screwdriver where a pliers is needed. You need to have everything in your toolbox, and depending on the problem, you should be making a decision and as to which one to use. And that's where most of our testing and learning comes at help as to which one to use. Okay, some AI methodologies that might be of interest to the IP community. The first is natural language processing and understanding. It's an AI method that interprets language such as English and decide how to respond to a request. And some of the common items are Siri, Alexa, which you are very familiar with. But there are more complex natural language processing, which not only does something based on your request, it kind of tries to make a continuous conversation as well. Then another method is general adversarial network, which is a deep learning method. And usually it tries to find a counter argument to a statement or an argument. Okay? And the third AI methodology, which I believe might be very important to IP, is recurrent neural network. It's a feedback deep learning method, which kind of goes and learns and commits things into the memory based on some time scale. And things can be used for understanding a sentence, meaning of a sentence, or kind of paragraph, how the sentences are formed, or a large text, depending on how paragraphs are formed. All right, now let's move on to how AI can help you, or big data can help you in the IP lifecycle. The first thing where AI can be really helpful is at the ideation or the invention stage of your organization. First of all, it can help you discern the technology trends, not just by using natural language processing or some methods to find out where people are filing patents or writing papers or writing books or newspaper articles. And based on that, you can decide where do you want to put your organization for the future competition. One thing to remember, AI always uses the historical trends to make a future prediction. So it cannot be really revolutionary. It's always evolutionary. If something new comes up, which it cannot foresee, it cannot help you there. So it's an evolutionary technology. Second thing is when you're talking about you have to defend your patent for defensive purposes or to your patent examiner. And there, natural language processing and understanding can really work wonder to find if there is any patent search or finding out. It's much better, much superior than just a keyword or phrase search, because it really tries to help understand with human help what it does the content mean. Another is the general adversarial argument, when you have to use some argument to make sure that your patent is actually valid or some patent is actually invalid for some counter arguments. The general adversarial network can really help if you can build it like that. Third is kind of the last stage of the in your valuation and monetization. I mean, one of the decisions an organization need to make is whether to keep or drop a patent. So natural language processing and understanding kind of can help you if you have a large patent portfolio, which are the best set of patents that you want to keep for valuation, monetization, defensive purposes or offensive purposes, and which one to drop. Okay, so it can actually help you to find the best set of patents for both defensive as well as offensive purposes. Okay, and again, you can use the natural language processing and understanding to find the competitive landscape where your competitors are filing patents, and you can actually decide which patents will be valuable for your defensive purposes, which one you want to save, and which one you want to sell, and which one patents which you can build for some defensive portfolio against your competition for freedom of action. So finally, as you mentioned, it does not replace human intelligence or insight, because it needs human guidance to find out to learn and make a decision. But it can does it so quickly and automatically that sometimes it can be really astonishing. So it can be one of the most powerful tools in your toolbox. And AI can also help manage your IP portfolio from the ideation all the way to monetization. Thank you very much for your attention. That's all.